Dr. M. Ponniyin Selvi, Associate Professor and Head Department of Commerce of this institution. In this video, we are going to learn about indices and logarithms. Repeated multiplication is termed as index. How many times a specified number is to be multiplied by itself is termed as the exponent or power. When we express x to the power n, x is called the base and n is called the index or power. Now we can see the three forms. When we say 125, it is numerical form, just a number. When we say 5 into 5, it is an expanded form of a number. A number 5 is multiplied by itself 2 times. When we say 5 cubed, it is in index form. Here 5 is the base and 3 is the index. For example, 5 to the power 4, it denotes 5 into 5 into 5 into 5. The numerical value is 625. So this table shows how an index can be expanded and how the value is arrived. 4 to the power 5 means 4 into 4 into 4 into 4 into 4. So the value comes to 1024. This arrow shows that index may be either in positive or in negative. To work out problems with indices, the rules to be kept in mind are: the first one, a to the power m into a to the power n is equal to a to the power m plus n. In the first 5 formulas, we should consider that the base is same. So when the base is same, the indices, if to be multiplied, is added. The indices are to be divided, then in the answer it is a to the power m minus n. When we say that a to the power m, the whole power n, the both m and n can be multiplied. And we should keep in mind, a to the power 1, that is the power 1 of any number is the same number. And the power 0 of any base is always 1. And sometimes the base may be different, but the indice may be same. Here, the indice is taken as a common one, or it can be considered for both. So these formulas denotes for different bases. We can convert the negative index into positive index by means of giving a reciprocal to it. So a to the power minus m can be written as 1 by a to the power m. For example, let us see, 9 to the power minus 2 is equal to 1 by 9 square. 9 square is 81. And regarding one fractional index, here we are having numerator and denominator. The numerator is x and the denominator is y. To convert it into root form, the y becomes the root. So we can write it as yth root of a to the power x. So by memorizing all these formulas, we can work out the problems in indices. Let us look for example, a simple example. 3 to the power minus 2. So the 3 to the power minus 2 is in negative index. It can be written as in the form of positive index by giving reciprocal. So it is 1 by 3 square. So 1 by 9. Then 81 to the power 3 by 4. 81 is a very big number. Whenever there is a very big number, we have to convert it into a smaller base. So 3 to the power 4. See, 81 is arrived as 3 into 3 into 3 into 3. So 3 to the power 4 into 3 by 4. Now this index is coming in the form of a to the power m, the whole power n. So what happens? We have to multiply this 4 with the 3 by 4. So 4 can be cancelled and we will be getting only 3 cube. 3 cube is 3 into 3 into 3. So we are having 27. And here also again a to the power m, the whole power n. So m and n can be multiplied. So now we are getting only 9 to the power minus 1. 9 to the power minus 1 can be written as 1 by 9 to the power 1. But here we are having division form. So when we have division form, a to the power m divided by a to the power n is a to the power m minus 1. So 1 by 9 into 27 and into 9. Because the division has been converted into multiplication. 9 and 9 can be cancelled and the answer is 27. So when we want to work out any problem with the indices, we have to keep in mind all these rules. Applying any of the rule, we can find out the answer, we can simplify, we can evaluate. The next form of index, that is the next step, next advancement is logarithm. Logarithm is a simple mathematical tool to solve any complicated multiplication and division and root problems. Here also there are some basic rules. Log 1 of any base, log 1, is 0. And when the base and the number are the same, log b to the base b is equal to 1. And when log mn to the base b, that is two numbers are to be multiplied, then when separated it is log m to the base b plus log n to the base b. Then for quotient rule we can write it as log m by n equal to log m minus log n. Power. Index rule. When we write it as in the form of index, very simple, the index is to be multiplied. So it has been brought to the front. Also we can change the base. When we want to change the base, we have to introduce a common base. Here log b to the base a. We are going to introduce one more new base c. So it can be written as log b to the base c divided by log a to the base c. Again we can cross multiply this one also. So keeping these formulas in mind, we can work out any problem in logarithm. When we say log, we mentioned only common logarithm. For common logarithm, the base is 10. So for common logarithm, we have to refer logarithmic table and anti-logarithmic table. When we are going to find out the log value, we should consider the log table. So here we are going to find out the log value for the number 31.62. First we have to find out the mantissa. How to find out the mantissa? For 31, the row 31, the sub-column 6 is considered. So here the number we are having is 4997. With this, we have to consider the mean difference column 2 because the number is 31.62. So in the mean difference column, we are having the number 3. This 3 is to be added with 4997. So we are getting the value 5000. So this is the way of finding out the log value. When we are finding out the log value, just mantissa we have looked at. Mantissa will always be in positive. Now we have to come to the characteristic part. How to find out the characteristic part? We have to count the number of digits in the number. Here the number is 15. So in the number 15, how many digits are there? 1 is 1 digit and 5 is 1 digit. So totally there are 2 digits. We have to subtract 1. So 2 minus 1 is equal to 1. So number 1 is the characteristic and 0.176 is the mantissa. We have to keep in mind mantissa will always be in positive, but characteristic may be either in positive or in negative. Now let us look into some more log values. If the number is 45,600, here there are 5 digits. So 5 minus 1, we have given the characteristic 4. In the same manner, let us come to 4.56. Here 4 is the only one digit. So 1 minus 1 equal to 0. Again, when we go for decimal numbers, for example, 0.00456. Here, there is no round number. Also, after the decimal point, there are 2 zeros. So, totally, we have to give minus 3 as characteristic. Now, consider the mantissa. The mantissa is the same for all the numbers. So, when finding out the log value for the same number of any digits, the characteristic will only differ, but the mantissa will be the same. Consider the logarithm value. In mantissa, it is always in positive, but coming to characteristic, it may be either in negative or in positive. So, in this way, we have to find out the log value with the help of log table. In index, let us see one problem. See, it's in general, a to the power m equal to k means, here a to the power m is a normal index, m. M means we can say m by 1. But when the index is to be exchanged from left side to the right side, it is brought as reciprocal. That means it can be written as a is equal to k to the power 1 by m. So applying this rule, now let us prove that 1 by x plus 1 by y plus 1 by z is equal to 0. We have to prove this. But they have given two formulas, two equations. X to the power y is equal to y to the power z is equal to z to the power x. This is one equation they have given. And another equation they have given is x, y, z is equal to 1. Now, let us take the first equation. X to the power y equal to y to the power z is equal to z to the power x. This only they have given. But what we have to do is, for all these three, we are giving one more unknown value as k. So, we have inserted these three are equal to k. We have just assumed. Now, we are separating into three equations. X to the power y equal to k, y to the power z equal to k, z to the power x equal to k. Okay, so first we introduced k as the value. Then we are separating into three equations, and now to make the base same, to make the base k, we are doing x is equal to, what will happen? The y should go to that side, so it is converted as 1 by y. So x is equal to k to the power 1 by y equal to k to the power 1 by z. And z is equal to k to the power 1 by x. So now let us see, all are having the same base k. Now, we are going to multiply these three, x, y, z. So when we multiply, it is k to the power 1 by y into k to the power 1 by z into k to the power 1 by x. So we know the formula, a to the power m into a to the power n is equal to a to the power m plus n. So the indices are added, 1 by y plus 1 by z plus 1 by x. Now, in our left hand side, we are having x, y, z. Now go to the second equation given in the problem, x, y, z is equal to 1. So now we are taking it here, x, y, z is equal to 1. We have also learnt that if there is the 0 as an index, the value is 0. For 1, we may substitute a value k to the power 0. So for 1, we are substituting k to the power 0. And for x, y, z, we are having the first equation, k to the power 1 by y plus 1 by z plus 1 by x. Now let us compare. The bases are same. So when the bases are same, the index can be equated. So when we are going to equate, 0 is equal to 1 by y plus 1 by z plus 1 by x. So we can exchange as 1 by x plus 1 by y plus 1 by z is equal to 0. So here what is the basic point is, we have to assume one answer as k and we have to proceed. So in this way, whatever may be the problem, it can be solved with the help of any of the formula of indice. Now let us come to one more problem with regard to log. Here we are not going to refer log table. Simply we are going to apply index formula. Now the number is log 243 to the base 3 into root 3 is equal to x. We are going to solve the problem. We are going to find out the value of x. So what we can do is, we have to convert this log form into index form. For this purpose, what we have to do, just we can remove the log first. Here what is the base? 3 into root 3. The base is kept as it is. The base is as it is. Just we are going to exchange these two. The 243 is going to the right side of the equation and x is coming to the index part. Okay, so by this way we can convert log number into index number. Now what is 3? 3 can be written as 3 to the power 1 and root 3 can be written as 3 to the power half, 1 by 2. So again it is in the formula of a to the power m into a to the power n. So I am adding these two, we are getting 3 to the power 2 by 3 by 2. Now this is in the format of a to the power m the whole power n. So it is written as 3 to the power 3x by 2. Coming to the right side, here we are having 243, but in the left hand side we are having the base only 3. So this 243 should be converted into a number with a base 3. So 3 into 3 into 3 into 3 into 3, we are getting 3 to the 5, the answer is 243. So it is written as 3 to the power 5. Here bases are same, so index can be equated, 3x by 2 equal to 5, 3x is equal to 5 into 2, 10, so x is equal to 10 by 3. So with the help of index, even log problems can also be solved. Then coming to one more problem, here also what we are doing is, instead of looking into the log table, a very big log number, here log 72, this 72 is splitted into small numbers. If you want to solve any problem, we have to split a big number into a small number. So how the 72 is splitted is 2 cube into 3 square. And again, log 2 cube into 3 square means, by applying one formula, that is in the log formula we have studied, when two numbers are to be multiplied, they have to be separated and added. So in this pattern, we are going to separate the number log 2 cube. Here it is multiplied, but when it is separated, two log numbers have been come, log 2 cube plus log 3 square. And already there is one log 3, so it is given as minus log 3. And again 27 can be written as 3 cube and 64 can be written as 2 to the power 6. Here the logic is, any big number should be converted into a small number in its index form. So another formula, when there is index in log, the index is to be brought forward, brought to the front, and it should be multiplied. So it is written as 3 log 2 and this number is written as 2 log 3. So what is going on? After simplifying, we are having in the numerator 3 log 2 plus log 3 and in the denominator also we are having 3 log 2 plus log 3. So both can be cancelled and the answer is 1. So in this way also, without referring the log table, we can solve the problem. Now, with the help of logarithm book, how to solve a problem. Now what they have asked is root of 0.008109. We have to solve this problem with the help of log. Let us keep the answer as x. Now take log both the sides. So log x is equal to log of this number. And whenever there is root, a problem cannot be solved. So the root form is to be brought into index form. So the power 1 by 2 has been brought. And then by applying the log formula, this 1 by 2 is brought to the front, 1 by 2. Now, we should refer the clocks table, log table. Here the number is 0.00. So the characteristic is minus 3. Minus 3 can be written as bar 3. And the mantissa value is 0.9090. So we have found out just a log value. But it should be divided by 1 by 2, isn't? So what we should do? We should do separately for mantissa and characteristic. See, they have characteristic is minus 3. So minus 3 by 2. The mantissa is plus 0.9090. So divided by 2. See, when we are dividing the characteristic, the answer should be a round number. So what we can do is, for this minus 3, we can subtract 1 and we can add 1. Minus 3, minus 1, plus 1. The minus 1 is written here and the plus 1 is written in the mantissa side. So minus 4 by 2. Minus 4 by 2 is minus 2. And here 1.9090 divided by 2 is 0.9545. See here the characteristic is in minus. So it is written as bar 2. Bar 2.9545. So this is the value of log x. But we need the answer for only x. So for this we have to find out the reverse value. That is, we should find out the anti-logarithm table. In the anti-logarithm table, first we should find out the value for 0.9545. So here the value comes for 9005. But now look into the characteristic, it is minus 2. So after the decimal point, we have to insert 1 0. So now the answer for root of 0.008109 is 0.09005. So by working out many more problems, we can solve a difficult type of and a complicated type of root problems, multiplication problems and index problem also. So we can try this problem also. We can get the answer, a very simple answer. But in order to solve all these problems, we should be well versed with all the formulas or all the rules, indices rules and all the log rules. So let us learn all the log rules and indices rules and we can solve all the problems in an easy manner. Thank you.